All right, you guys, so I told you I'd tell you a little bit about how to do the last 3 problems in the calculations and analysis section, or the last 4. So let's talk first of all about 1 and 2. 1 is just defining the term alloy, research the alloys, and determine the components of them. So you have to research steel, bronze, brass, and white gold. Super simple. Google search for that. Number 2, we talked about this before we left today. It says using y equals mx plus b. Remember, you have that formula. It's going to be different for each group. It says the absorbance that you recorded in step 11 determine the molarity of copper ions in the solution made from the brass sample. Super, super important. And then you're going to compare it to what you estimated from step 10. So like, were you pretty close? Were you far off? Again, your answer to that doesn't matter, but you do have to answer that. So tell me how it compares to your estimated value from step 10. What really we're going to focus on right now is we are going to focus right now on how to do the rest of the lab questions. So number 3, using the molarity, sorry about the typo, molarity of copper ions in stoichiometry, calculate the number of grams of copper in the brass sample. All right, so the first thing you guys are going to notice is it does require you guys to use stoichiometry to calculate it. And you might be wondering, where's the equation? The equation you're going to use for this one is the equation from the beginning of the lab. Now, you guys know, we talked about this today, that anytime you do a reaction or you talk about using stoichiometry, you need to write the balanced reaction. And so the expectation here when you guys do number 3 is that you do go ahead and write that balanced equation. I know you've already done it once before. You're going to have to do it again. All right. That being said, let's talk a little bit about this problem. It says using the molarity of copper ions. Okay, the molarity of copper ions they're talking about is your answer from question 2. Okay, so you're going to have some sort of molarity of copper ions. So I'm totally going to make up a number. So let's say, for example, my molarity of copper ions that I found with my group was 0.147 m. Okay, so let's say that's what I found from the y equals mx plus b equation. Let's talk a little bit about that. That's my molarity of copper ions. Okay, that's how much copper ions are in the solution, again, based on Beer's law. Now, one thing that it gives you as a hint, it says, remember, there was 100 milliliters of that solution. If you remember, I dissolved the brass sample in just like 10 milliliters of nitric acid, and then I diluted it up to 100 mils. We have to take that into consideration. So first thing we're going to do is we're going to go ahead and use the molarity equation, m over 1 equals moles over liters. And we're going to figure out how many moles. Remember, the whole thing about stoichiometry is we need to get to moles. So we're going to find moles of copper ions. So I've got 0.147 m over 1 equals x moles over, and how many liters was it? Well, it was 100 milliliters, so it's 0.100 liters. I am going to go ahead and cross multiply those numbers. So I'm going to cross multiply those numbers and get an answer. And so once I get that answer, that's moles of copper ions, right? That's what we were looking at. All right, so moles of copper ions, they don't want to know moles of copper ions, they want grams of copper. So here's where I need to go to my stoichiometry. For every 3 moles of copper ions, I started with 3 moles of copper. Now I know it's a 3-to-3 ratio, but we still have to show it. So 3 moles of copper ions per 3 moles of copper. That's just to get us into copper. Now think about it, ions don't weigh anything. The metallic copper is what weighs something. So this is the copper we're trying to get to. Now it's not asking for moles of copper, it's asking for grams. I would do one more box and do the molar mass of copper. I'm going to let you look that up. 1 mole of copper is blank grams of copper, and that is it. So for problem number 3, you do need to show the balanced reaction. Again, use your answer from question 2. That's going to tell you your molarity of ions, cross multiply to get moles of ions, and then use mole ratio and formula mass to get to grams. All right, question number 4. Pick a different color so it's a little easier to see. Calculate the percentage copper and brass. All right, so the percent of something is always equal to the part over the whole and then times 100. Well, you know very well from your answer to number 3 how many grams of copper you had, right? So you're going to have your answer from number 3. That's going to be your grams of copper. And then you're probably wondering, what do I put down here? What was the whole mass? It's our grams of brass sample that we had. So I had you guys write that down for me. Some of you should have it somewhere, how many grams of brass there were that I started with. So your answer from number 3 divided by the grams of brass that I told you the very first day of the lab, that was last Friday, and then times 100 will get you a percentage. All right, very last one. Let's take a look at number 5. Assume the calculation for the amount of nitric acid was too small. How could this impact the calculated percentage? All right, so let's talk about that. We need to be better at following through this math, you guys. We can't just write vague answers like it would be off or it would be different. You have to be like really, really good about answering, will it be too big, too small, that sort of thing. So if the amount of nitric acid is too small, think about it for a second. The point of the nitric acid was to get all of the copper dissolved, right? So if I have too little nitric acid, that means not all the copper will dissolve. And I want you to think about what that's going to do to the solution. If not all the copper will dissolve, we are going to have fewer copper ions in solution, won't we? Think about the color. You're going to have a color that is less blue. Now, if there are fewer copper ions in solution, that means I have fewer copper moles in solution. That means fewer copper grams, and that's going to lead to a lower percentage of copper. It is important to show all of that math when you guys are talking about question number 5. Last but not least, I didn't put it on here, but question number 6 should be really, really simple. You're just looking at those 3 test tubes and labeling which one is which. If you want to just go ahead and put a letter A for the first one, a B for the second one, a C for the third, and just tell me which one is 0.40, which one's 0.20, and which one's 0.10, that will totally work. All right, that should be enough for you guys to finish the entire lab report. Remember, it's really important you guys pay attention to detail on this one and include everything that's expected that we have talked about. All right, good luck working.